Hello, in this video we're going to try to learn a way to change a recurring decimal to a fraction. This is an interesting problem because you can use some tools, linear equations, things like that, which some people may not expect to see in a decimal situation. So the type of problem we're talking about is a situation where you have a recurring decimal that has a repeating number like this, 3, 3, 3, 3, and it doesn't have to be just one digit. It could be 2 or 3 or 4 digits. You can have 80, 80, 80, 75, 750, 750, etc. And the idea is, how do we find the fraction that corresponds to that decimal? Now, if you don't have a recurrent decimal, like let's say you have a 0.25 and it's not repeating, this is relatively trivial because you can just do 25 over 100. Okay, and using the properties of fraction, and you can find it. But in this case, it's not as easy because you have this recurrent that it goes forever. Okay, it goes to infinity. Okay, so the strategy that we're going to try to do for this is to develop a process to get rid of the recurrent portion of the decimal by subtraction. What do I mean by this? So let me show you a simple example. If I have a number like here, 3.3333333, etc., etc., and I subtract from that 0.33333, then by doing this subtraction, okay, I can eliminate or get rid of this recurring portion because this subtraction is equal to 3. Okay, so we're going to try to exploit that configuration to try to find to do a process to find the fraction. But at this point, this is the trick. This is the direction of the strategy to solve this problem. Okay, so this is the process. Okay, that we're gonna. So we have here. We're gonna put the problem here, and then we're gonna set up an equation. Okay, and the equation basically is gonna be f equal to the decimal that we're trying to transform into a fraction. Now, here we're gonna manipulate this equation in such a way that at the end I'll have two representation of the decimal in such a way that if I subtract one from the other, I can eliminate the recurrence. So that's the trick that you have to do. You're exploiting that thing that I mentioned to you before. So you do by doing that, you're going to have a fraction. I'm sorry, an equation here, and then you're going to multiply the equation using the property of equations, both sides by a number, either 10 or 100 or 1,000, depending on the type of repetition you have in the decimal. And you're going to multiply both sides, and then you're going to end up with one equation. Now, the trick is to do this multiplication so that you only have in the decimal part that repeating portion. You have it again and again and again. Now, then you do this again with the same equation. You multiply, I say by 1 here because one of the equations, you may just have to leave it the way it is. And then do the next portion. But if not, you may need to multiply also by 10, 100, 1,000. And at the end, you're going to have two equations with the condition that they should not be the same. So you're going to have two situations. You're going to have two equations, right, that they are not the same. And in the decimal portion, you're just going to have in the decimal, you're going to have only the recurring part, okay, the repeating part. Now, when you have those two equations, you can subtract one from the other, and that's how you eliminate the repeating part. So you're going to end up with an equation without a recurring part, and then you just solve for f, which is what you're looking for. Okay? You do solve and simplify. So that's the general idea. So let's show an example here. 0.3333333 goes forever. Right, here I have the equation f equal to 0.3333, and now I'm going to do the manipulation. So I need to multiply by either 10, 100, or 1,000. Of course, you pick the easier one. In this case, you just multiply by 10. Okay, this is the first, the minimum number. You have to do the first equation, and you end up with 10f equal to, and using the property of decimals, if you multiply by 10, you move the period 1 to the right, and then you end up with 3.33. So here you have a decimal in this portion, a number with a decimal that has the repeating part over here. Now, for this part, I don't have to do anything because it's already so it's already configured in such a way that the repeating part is right here. So here you have the situation that I mentioned at the beginning, okay, where you can subtract the two equations. So 10f equal 3.3333 minus f equal to 0.3333. I can subtract 10f minus 1f is 9f. And here when I subtract this, I get rid of the repeating part. So then I have a simple equation that I can solve, f equal to dividing both sides by 9, and then I simplify and get f equal to 1/3. Okay, that's one example. Let's check another example. Now in this case, the repeating part is 0.18, 18, 18, 18, and 18. Okay, so in this case, I cannot multiply by 10 because I will end up with 8, 18, 18, 18. So I don't satisfy the condition that I only want the repeating part in that portion. So I have to multiply by 100. Okay, then it gives me 1, 8, so 18 point. So I multiplied both sides by 100, so 100f and 18 point, and I got again the repeating part over here. And now you can see the pattern. If the repeating portion has 3 digits, you multiply it on 1,000, and this is 4 digits, you multiply by 10,000, and so on and so on. Okay, now over here we don't have to do anything because it's already only the repeating part. So I can take both equations, okay, 100f equal 18, 18, 18, and subtract f. And by doing this, I will get rid of the repeating part. And rid of 100f minus f is 99, and this is 18. And give me f equal 99, f equal 18, divided both sides by 99, gives me this equation, and then I simplify. Okay, so let's do one last one where you have to modify both equations here to get what you need. So this is the last example. So this one is 0.6, okay, and then 80, 80, 80, the repeating part. So this decimal does not have is not repeating. You have an extra digit in there. So same procedure, we say f equal to 0.6888, okay, and then to have an equation where only the repeating part is 80, 80, 80, I just need to multiply by 10 in this case, okay? So then I have 10f equal to, multiplying by 10 is 6.80, 80, 80, 80, 80, and I have the condition that I need, the repeating part in the decimal. Now, I need to do that over here. Now, I cannot do like in the other two problems, just basically copy, because this equation here, this representation does not have only the repeating portion that I need to have so I can cancel it. Now, so one way to do it will multiply by 10, right? But I already have that. And remember, I cannot have the equation the same. And the reason is because if I have the same equation in both sides, when I subtract them, it's going to give me 0 and 0. It doesn't help me. Okay, so I need to multiply by a different number. Okay, so I cannot do 1 because it's not repeating. I cannot do 10 because it will the same equation as this one. So I gotta go to the next one. I cannot do 100 because that will give me 68, 0, 80, 80, 80. So I still have that 0 bugging me here. So I have to multiply this equation by 1,000. Okay, so then I will have the 80, 80, 80, because if I multiply by 1,000, I will move the period, the three places to the right, and I end up with what I need. So it's 1,000f equal to 680, divided by that, and then I have 80, 80, 80, 80, and so on. Now I need to subtract. Now in the other problem, I subtract this minus that because the bigger number was in this side. In this case, I will use this. It's the bigger number. It doesn't matter. You're just going to get a negative number if you do it from this way. So it's just easier to do it from this bigger one. So I have 1,000f equals 680.808080, and then this equation minus 10f equal to point, and I added those 0 here so the dot kind of align with each other. You really don't need those, so it's actually 6.808080, and then we subtract 990f, subtract over here 674, and then I solve the final equation and I simplify. Okay, and this is the last problem. I mean, this is a very cool problem just because you used this is the beauty of math. You have a different tools that you can use to solve specific portion. Like in this case, a decimal problem, but in order to exploit the strategy that and execute the strategy that we took in the first slide, you need to be able to use tools from in this case, from equation from algebra, all right? And that's how you convert a recurring decimal into a fraction.